chat. Okay, a lot more people joining. Just to admit everyone. Everyone's connected to audio. Good morning, sorry, good afternoon in about a minute. Good afternoon, everyone. I hope you guys are all doing well. I can see you guys are connecting to audio, so I know some of you can and cannot hear me. But good afternoon to everyone. Hope you guys are all doing well. I can see a lot of familiar names in the chat. So I can see there's a couple of students that I do teach and some unfamiliar names. But just before we start, just going to do a quick intro. So for those of you that don't know me, my name is Daniel. I'm a GCSE and A-level maths tutor, and I teach online, and I've been doing so for about 5 years. And yeah, I run classes every week. And today we're just going to go over a couple of random past paper questions. So there's a lot of people joining. So I'm just going to give a couple of seconds just so everybody can hear me. Everybody's connected. So a lot of people still joining, so I'm just going to let everybody in and we'll make us start very, very shortly. But yeah, so what we're going to do today is we're going to go over a couple of past paper questions that I've picked out from different papers. I'm going to give you a chance to go for it first, and then I will go for it together with you. And I'm just going to let everybody in. Wow, there's a lot of people today. A lot of people. You guys must have an exam coming up. But yeah, what I'll do is I'm gonna share my screen and we'll make a start. So let me get my whiteboard up. Just give me a sec. Okay. So here are the higher questions that we're doing today. So before we go through the questions, I'm going to give you a chance to go through it and then we'll go through it together. Now, while I'm explaining anything to you guys, if there's anything you want me to go over again, then you're more than welcome to just drop a message in the chat, or you can just raise your hand and ask a question. Yeah. So I'm just going to give a couple more seconds just so everybody's in. Can you guys all hear me, by the way? Can somebody just drop me a message in the chat just so that you guys can hear me clearly and there's no glitching or anything? It's all clear? Cool. Thank you very much, Wasim. All right, cool. So we're going to do the first question. It's 1 mark. And let me just, there's more people joining. Wow. You guys are really, really focused and very dedicated. I appreciate all of you guys joining today. I'm just making sure everybody can hear me. There's a couple of people that haven't connected to audio yet, but I think they will be able to soon. But yeah, cool. So we're going to start with the first one. It's 1 mark. Because it's 1 mark, I'm going to give you 1 minute to try it. Now, after the minute, please put an answer in the chat and we'll go for it together. So this is the first one. 2a is 5 times bigger than b. Circle the ratio a to b for 1 mark. I'll give you 1 minute to try it and then we'll go for it together. I'm going to look at this question though. What do we feel about it? Put a 0 if this is confusing. I have no clue what to do. This is very difficult. And put a 10 if this is super easy. I know exactly what to do. I want you guys to all give me a number between 0 and 10, just so I have an idea as to how we are all getting on with it. I can see an 8. I can see an 8. Good stuff. Good stuff. Wow. There's 24 people today. Wow. Incredible. Incredible. Okay. You see 2 8s. So I'll give you about 30 seconds more and then we'll go for it together. Okay. Wow, there's so many people trading today. That's crazy. Okay. I'm just making sure everybody can hear me. Good afternoon to anybody that just joined a few moments ago. We're just going over the first question today. Okay. So it's been about a minute. Now, what is our answer, guys? Can everybody please put what they think in the chat, please? Remember, you can message me directly. So if you don't want everybody else to see your answer, that's not a problem. So what do we think? Is it 10 to 1? Is it 1 to 10? Is it 5 to 2? Is it 2 to 5? What's the answer? Okay. I can see 1 to 10. I can see 5 to 2. I can see 2 to 5. Cool. So let's go through this together and let's see. So I'm going to put this here. Copy. All right. Now, we've got this here. Now, for me, I've got a sentence here. 2a is 5 times bigger than b, right? And we need to circle the ratio a to b. Now, this sentence here is some sort of algebraic sentence. It's one of those statements where you can translate it into some sort of mathematical equation, right? Now, I've got this here. I'm going to break this into parts. I've got 2a, right? I've got the word is, and then I've got 5 times. I've got 5 times bigger than b, right? So for me, I'm going to break this down into parts, right? I've got 2a. Now, can somebody tell me, please, what is the word is in maths? What mathematical symbol can I replace the word is with? Thank you very much. It says Q as your name. So thank you very much, Q. I know probably you just let me know your name. And thank you very much, Naya. It's equal. Yeah. So I'm going to put equals here. And then it says 5 times bigger than B. 5 times bigger than B. What does that mean? Well, that just means 5 times B, doesn't it? Right? Or we can write this as just 5B, can't we? Yeah. So now I've got this here. Now we need to find a ratio and we've got an equation. Now, whenever you're doing these types of questions, whenever they ask you to find a ratio when they give you an equation, what you want to find an expression for A divided by B, right? Because what will happen is that you'll have a number on the numerator, you'll have a number on the denominator, and that will be your answer. Yeah. So we've got 2a is equal to 5b. How can I get a divided by b on its own? Well, the first thing that I can do is I can divide both sides by this b here, right? If I divide both sides by b, this will give me 2a divided by b is equal to 5, right? Now, remember, we're trying to find a divided by b. The problem here is that we've got a 2. This 2 needs to disappear. How do we get rid of this 2? Well, it's on the numerator. It's multiplying. So I'm going to divide both sides by 2. Yeah? Divide both sides by 2. Divide both sides by 2. This will give me a divided by b is equal to 5 divided by 2. So now we can see clearly a is equal to 5, b is equal to 2. So the ratio a to b is clearly 5 to 2. Yeah? That is the answer. And well done to anybody that got this correct. There's quite a few of you in the class today, so I'm sure some of you got this correct. For those of us that didn't get this correct and put a different answer, is this clear? Whenever you're doing these types of questions, if they give you some sort of equation, in this case, we have to get the equation. If they give you an equation and they want you to find a ratio, you find the letters, right? So you'll just find this, for example, if they said, for example, I don't know, let's just say, I don't know, x is equal to 5y or something like that. And they say, find the ratio x to y. All you're going to do is figure out what x divided by y is. X divided by y is equal to 5, which we know is over 1. So this is just going to be 5 to 1, stuff like that. Is that clear, guys? Yeah? Cool, cool, cool. So let's continue. That's the first one. Let's go to another one and see how we got on. Yeah? Wow, there's so many of you guys today. Fantastic, fantastic. Okay, now we've got this one here. Now, remember, we've got paper 2 coming up. We know that bounds is for sure going to come up either paper 2 or paper 3. So have a go at this one, see how you get on, and then we'll go through it together in about 4/5 minutes. Yeah? I did B over A. Hold on, let me just double check something. Sorry, 1 second. Did I do B over A? So I've just got, sorry, just 1 second. I've just got a question in the chat. How comes you did B divided by A and not A divided by B? Did A divided by B? Let me just double check. Yeah, A divided by B, because I did A divided by B because I wanted the ratio A to B. Yeah, I didn't do B divided by A. Is that clear? Is that okay? Just for anybody that had a question. Yeah, just let me know in the chat. Put you back onto that one. Yeah. So anyways, we've got this question there. We've got bounds. Yeah, we've got bounds. How do we find bounds as a question? Put a 0 if you don't like these questions, struggle with them, don't like them at all, and put a 10 if these questions are super, super easy. You know exactly what to do. This is not a problem. I want you all to give me a number between 0 and 10. Okay, I can see an 8. I can see a 0. I can see a 10. I can see 7s, 8s. I can see 0s. I can see 1s. Okay, cool, cool, cool. Okay, so for those of us that are a bit close to the 0 side, that find this a bit difficult, what you want to do with these types of questions, right, is very straightforward. I'm going to give you a couple of steps. I'll start you guys off, right? We've got this here. It says 2 sides of a triangle are measured to 1 decimal place. So for me, what I do with a question like this, right, is I say, well, if it's one decimal place, that's just I get a little table like this, yeah, and I do my place values. So for example, let's just say this is a ones. Let's just say this is ones here. Let's say this is tenths. Let's say this is 100ths. And let's say this is 1,000 and so on and so on. So I always do with these bounds questions. Now, ones is just one. 1/10 is 0.10. This is 0.01. This is 0.001, isn't it? And so on and so forth. Now it says measured to the one decimal place. So I look on my place value. Where is one decimal place? That's 0.1. So what I do is I take that number 0.1. I'm going to half it to give me 0.05, right? And then to get the bounds of any distances, I'm going to add and subtract that value from whatever the values they're given to us, right? So they said that there's two sides is that. So if I wanted the upper bound of 7.2, I would do 7.2 plus 0.05. To get the lower bound, I'll do 7.2 minus 0.05 and so on and so forth. Yeah? Does that make sense as a starter? Right, exactly, exactly. And then another thing as well, we need to work out the upper bound of the area of the triangle. Another thing too, well, this is clearly trigonometry, right? It's not a right angle triangle. Can somebody tell me the formula for working out the area of a triangle such as this? We've got two sides of the angle between. Can somebody tell me the formula in the chat, please? Right, right. Thank you very much. Andreas, I think that's how you pronounce your name. Andreas Q. Emilio, thank you very much. It's half AB sine C. Yeah. So what you want to do is you want to use the formula half AB sine C and figure out what the bounds are. Yeah. So the area is a half AB sine C. Now remember, what they're asking you for is the upper bound for the area. Now the area is dependent on three variables, aren't they? It's dependent on A, it's dependent on B, and it's dependent on C, right? The variables A, B, and C change. Now, depending on what values you choose, will give you the largest area. So you need to ask yourself, okay, what bounds do I need if I want to work out the upper bound for the area such as this? Yeah, cool. So I will give you about 2 more minutes to have a go at figuring out the bounds, see how you get on, and we'll go through it together. Yeah. Just gonna give you a couple of seconds. Let me just this here. There's so many people today. It's so good to see. I'm just looking. Okay. Do you find the upper bounds of all the values? What I always do is I find the upper bounds and the lower bounds for both, and then just gauge which ones I need. Yeah, so we're gonna go through it very shortly. Last few seconds. If it doesn't tell you or what to round your answer to, you should always give it to three significant figures. Yeah. So give you a few more seconds and we're going to go through it together. Let's take it something. Okay. Okay. So let's go through this together and let's see what we've got here. Yeah. So let me put this here actually. Sorry. Put this here. Put this here. So put this here. Let's see. So two sides of a triangle are measured to one decimal place. The angle between the sides is measured to the nearest degree. Work out the upper bound of the area. So first thing for me is I'm going to figure out the bounds of all of my different distances, right? So as I said before, that table, let me get up again, actually. Might as well just copy it, huh? So we got this here, right? So what we can do now with this one, the distances of the triangle are to 1 dp. So 1 dp is to 0.1, isn't it? So therefore I half 0.1, half 0.1, this gives me 0.05. So therefore I can work out the upper and lower bound for the two distances. So I'm gonna write for 7.2, right? The upper bound, right, would equal 7.2 plus 0.05, which is 7.25. And then for the lower bound, we would subtract that number, wouldn't we? Yeah, lower bound, we would do 7.2 minus 0.05, which would be 7.15, isn't it? 7.15. So these are our upper lower bounds for 7.2. And then similarly, for the 13.6, right? 13.6, the upper one would be just 13.6 plus 0.05, which is 13.65. And then the lower bound would be subtracting that, wouldn't it? Yeah. 13.6 minus 0.05, which is equal to 13.55. Yeah. So we've got the upper and lower bounds for the two distances. Now we need the upper and lower bound for the angle, right? Find the angle between the sides is measured to the nearest degree. Nearest degree for me, that means just nearest 1 degree, right? Nearest 1 degree. So we go to our place value, which is at 1. So we look at this number here. We're going to divide it by 2, aren't we? 1 divided by 2 is 0.5. So we're just going to add 0.5 to 110 and subtract it. Yeah. So therefore, we're going to get, for example, we get for 110, right? We're going to add 0.5. This will give us 110.5. This will be the upper bound for it. And then the lower bound would be 110 minus 0.5, right? Which is 109.5. How many of us got all of our bounds? This correct? How many of us got this? This all clear? Yeah, good stuff. Good stuff. Well done. All right. Now continuing. They asked us for the upper bound of the area of the triangle. Well, to answer this question, we need to know the formula for area of a triangle, which we know. The formula for the area of a triangle is a half AB sine C, isn't it? Yeah. So what we're going to do here is we'll say the upper bound. Why did you do the angle? As well as just the two sides are bounded. Oh, because I've just got a question in the chat. Why did I do the angle as well? Because it also said the angle between the sides is measured to be to the nearest degree, right? So this has also been approximated as well. Yeah? Does that make sense? You've got to read. So somebody just said that he didn't read that line. Be careful. Be careful. Make sure you read every single sentence, because if you don't read every single sentence, you may not get the whole answer. Yeah. So right now, we know that we're looking for the upper bound of the area. So I'm going to write area upper, right? Whoops, that is not how you spell area. Area upper. Yeah. Now, how do I do this? Well, I have a product here. I have a half times A times B times sine of C, don't I? Yeah. Now, Now, when you're doing these questions, right, you're looking for the different types of values, the upper and lower bounds that we would need. So can somebody give me a suggestion, please? Let's just say, because they haven't said, but let's just say, obviously, this is C. Let's say this is A and this is B, right? For the values of A and B, I want the upper bound. Which boundary do you think we would need for A and B? Up times up, okay? And you know that I agree with that because we're timesing together. How do we make the number as big as possible? We times by the bigger numbers, right? So we're going to get the upper bounds for both the two sides, yeah? So let's just say A upper. Let's say A upper here is equal to, what was A? We'll say A is a 7.2, so A upper is 7.25, yeah? 7.25, and B upper, right, is equal to 13.65, yeah? Right. Now, for C, right? Let's see this. I've got C, right, as the angle. There are two options for C. It could be C upper, C lower, right? Which one do we think we're using? Good. See, I've got a couple of different answers here. It would be, well, we're gonna see. Let's see what happens, right? Let's do both of them. Yeah, let's do both of them. If I do capital A for the area, A upper, right? There's two options. We could either use, it's definitely the upper bounds for the distances, but with sine, you've got to be careful here. So what were the two values? It was 110, 10.5, and 109.5. So let's put this here and let's see what that gives us. So it could be either this one, a half times 7.25 times 13.65, right? Times, let's use the upper bound, sine of 110.5. Let's put this in our calculator and see what this gets us, yeah? You guys can put it in as well, and you guys can just double check with me that you get the same thing I do. A half times 7.25 times 13.65 times the sine of 110.5. Yeah, putting this all in. This gives me, just make sure I've got it all correct. Is that correct? 13. Yeah, that looks fine to me. Click equals. This gives me 46.3477. 46.3477. Blah blah blah. Yeah, 77. Blah blah blah. Now let's try the 109.5. Let's see what that gives us. Right. This will just be 1/2 times 7.25 again times 13.65 times the sine of 109.5. Let's change it to 109.5 and see what happens. 09. Right? The numbers are very close, but this number is bigger though. Right? Do we agree? When I use the lower bound for the angle, the number is larger. So which one is the correct answer? It can't be the first one. It has to be this one. Right? Why does that happen though? Yeah? Why does that happen? Does anybody know why that happens? Why is it that when I'm choosing the smaller angle, I'm getting a larger value? Does anybody know? Well, what you need to know, right, is your graphs. Remember, you need to know the trigonometric graphs for sine, cosine, and tan, right? But if you think about it, let me know how much you remember, guys, about your graphs. I'm going to draw the sine graph for you, and I want you guys to tell me if you remember this, if you know this very, very well. It's a wave like this. It's a wave like this. It starts at the origin, has a maximum point here, goes down like this. This is the sine graph, right? Can somebody tell me, please, what that's very bad. Can somebody tell me, please, what the maximum and minimum values are of the sine graph? Does anybody know? What is the maximum and minimum? Thank you very much, Elio. It's 1 and -1. Thank you very much, Q. So your name is just Q in the chat, so I'm going to call you Q. But thank you very much. It's between 1 and -1, right? Now, we have a high point here. Can anybody tell me what value this is? That's at 90 degrees. Thank you very much, Emilio. It's at 90, right? This here is at 180. This here is 270. And this here is 360. But remember, let's look at what we have. Our angle was between 110.5 and 109.5, which is in between 90 and 270. But what is happening to the graph? the graph is going down. It's decreasing. So can we see that the larger the angle gets between 90 and 270, the smaller the value will become. So remember, we had a value of 109.5, which is just, for example, let's just say somewhere around here. 109.5 is around there. We can see from the graph that 110.5 is a little lower. That's why. Does that make sense? So when you're doing these types of questions, you've got to be very, very careful. For me, when I saw this question, I saw this is 4 marks. This looks easy. But then I said, hold on. I know how trigonometry works and I know how exams work. They want to try and trick you. Remember, if something is always so straightforward, most of the time it is, but just be careful. Yeah. So it's not the upper angle that we're using the lower angle. Yeah. So therefore, the answer would be that one there. And they didn't give us a degree of accuracy. So I would put it to 3 significant figures. Yeah. 46.6. 46.6. Yeah. Does that make sense, guys? Centimeters squared. Is that correct? Did anybody get it correct, by the way? And for anyone that didn't get this correct, is this okay now? Does this make sense? How we go about this? Yeah. Well done. Well done, Q. Well done, Anilio. Good stuff. All right. So we're going to continue now. Let's do another one and see how we get on. So what do I want to do next? We're going to go into that one in a bit. Let's do this one because this is another one that hasn't come up, I don't think. So we're going to do this one here. I'm going to copy this. I'm going to give this to you guys to do. So here's the question. I'm going to put them next to each other so you can see all of them. So they've given us this original graph here. I'm going to zoom in so you can see them, right? So this one on the left is the question. This is the question, and you've got part A and part B, yeah? So this is the question. And then can you guys see that clearly? Do you guys need me to zoom in a bit or is that clear? Just let me know in the chat if that's all clear, if you can see the questions. And it's about 2 marks, right? So not a lot is required. So I'll give you about 2 minutes to try it and we'll go through it together. Just a couple seconds, guys. I think somebody's trying to join and they can't get in. Let me just send a link to them. Oh, zoom in, zoom in. Do I need to zoom in? Sorry, I've just seen a message. Do I need to zoom in? You guys sure? Just let me know. And how are we all getting on with this as a question, guys? How do we find this as a topic? Put a 0 in the chat if you have no clue what to do, very confused, and put a 10 if this is super, super easy. I know exactly what to do. You can see a 7, cool. You can see a 7, cool. 5, 0, okay. For those of us that have put a 0, some of us may not have done this before, which is fair enough. This is a year 11 class. So there's some of us that maybe are not in year 11, you may not have done it yet, which is understandable. So no worries. But what I'm going to do, we're going to go through it in 30 seconds. Before we go through it, I'm going to show you some formulas and some rules that you need to know to answer questions such as this, right? But no worries if you haven't done it before. Yeah. Okay. Cool. All right. So let's what I'm gonna do, it's been about 2 minutes. Let me get the formula that I'm thinking of. Yeah. So when did I do it? I did it with the higher class 11, and then I did it. When did I do graph transformations? 3rd of January. So for those of you that are in my group classes every week, you guys have definitely seen this before. So for those of you that are in my classes, I want you guys to tell me how well you know this. Let me just go back to our lesson today. Okay, cool. So this table here, right? And for those of us that are in my year 11 classes every week, you would have definitely seen this before. But everybody, I want you guys, so you don't need to know the bottom 2 for GCSE, the top 6 graphs here, the top 6 rules here, transformation rules for functions. I want everybody in the chat, there are 31 of you, I want everybody to tell me how well we know these. Put a 0 if you have never seen this before in your life. No clue what's going on here. Is this even GCSE maths? And put a 10 if I know this extremely well. I can recite these no problem. I want everybody to give me a number between 0 and 10. Okay. Okay. So let me see. Let me see. So I can see a 9. I can see a couple of zeros. I can see a 5. I can see a couple of zeros. I can see 8s. I can see 5s. I can see 8s. I can see 5s. Okay. Okay. Cool. Cool. Yeah. So for those of us that are putting zeros, I'm assuming that some of you guys are not in year 11 because this is probably a topic that they teach in year 11. So no worries if you haven't seen this before. It's understandable. So is that the correct assumption for anybody that put a 0? Okay. Okay. Now for this one, basically with this type of topic here, graph transformations, what you need to do for the exam, right, is you need to know these 10 out of 10. You need to know all of these, how they work, what ones to use when you go in a question. You need to have these the way you know your phone number, right? So what we're going to do is we're going to do the question and use these rules. Yeah. So let's go to the question again. So the question says, here is the graph, here is a sketch of the graph y equals 5 to the x. In parts A and B, sketch the graph of y equals 5 in parts A and B, oh, the sketch of the graph is shown as a dashed line. Okay, that's fine. And then for part A, it says on the axis below, sketch the graph of y equals minus 5 to the x. So whenever you're doing these types of questions, you know it's a graph transformation question due to the fact that it's very similar to the original question that they've given us, the original function. But what you want to do though, before you even get started, you want to change your y's to f of x. You're going to write the question in function notation and you're going to see why. Yeah. So we've got y equals f of x. I'm going to say, well, instead of that, I'm going to say f of x is equal to 5 to the x, right? Now, all you're going to do is this with these questions. They're very, very straightforward, yeah? Now here, I'm going to move this here. All right. Now, I've got f of x is equal to 5 to the x, right? And then in the question, I've got minus 5 to the x. I need to sketch that graph apparently. Well, I compare this to my original graph. The only difference here is that I have a minus, right? Well, looking at the left-hand side, can somebody tell me what do I do to go from a 5 to the x to a minus 5 to the x? What have I done? And somebody's asked me what type of graph this is. I'm going to ask you guys in a second. But yeah, remember, we just times by minus 1. So all we've done to both sides is we're going to times by minus 1. So therefore, the actual graph that we're trying to draw is actually equal to minus the function of x. Does that make sense what I've done, guys? All I've done is I've compared my original function to the one that I need to sketch. And the only difference is that there's a minus. Now I've written it in function notation, I'll go to my table. Well, okay, I'm looking at my table and I'm going to label this 1 to 6, guys. Can somebody tell me, please? I'm going to say 1, 2, 3, 4, 5, and 6. Can somebody tell me which rule the question is? Which one of these 1 to 6? Can somebody tell me? Exactly. Thank you very much, Naya. It's clearly number 5. The minus is on the outside. Well, then you say to yourself, okay, well, what rule is that? What happens? It says it's a reflection over the x-axis. And what you're actually doing is you're timesing all of your y coordinates by minus 1, right? Reflection over the x-axis. Okay, that's fine then. Well, how do I reflect this over the x-axis? Well, it's just going to look like this. The graph is just going to look like this. Like that. The x-axis is there. If I reflect it in that, this is the graph. This here is the graph of y equals minus 5 to the x. Does that make sense, guys? That's why it's 1 mark. You just need to know your rules. Anybody have any questions on that just before we go to part B? Is that clear? Okay, cool. And before we go to part B, somebody asked me in the chat, what graph is this called? Can somebody tell me the name of this type of graph, please? What is this type of graph called? I'll give you a hint. It begins with an E. Thank you very much, AJ and Anelio. Exponential graph. This is an exponential graph. Thank you very much, Andreas. It's an exponential graph. How do we know it's an exponential graph? Due to the fact that it's in this format, y equals a to the x. Yeah. If you have a base here as a number and your power is a variable, it is an exponential graph. Yeah. Now, another question, do we draw it with dots or with a straight line? We draw it with dots. Sorry, we draw it with a straight line. We draw it with a full line, yeah? Because they just gave it to us. They dashed it because they're just basically telling you this is what you're going to use to help you figure it out. The actual question is going to be a full line, yeah? Which is why it's a full line here. You're going to draw it with a full line, but they wouldn't penalize you for that, yeah? Now, I've got another question for you guys. Can somebody tell me what the y-intercept, please, is of an exponential graph? What is the y-intercept always of an exponential graph? Can somebody tell me? Do we know it? Right. Thank you very much, AJ. It's 1. And if you didn't know it, how do you work it out? Well, the y-intercept is when x is equal to 0. So, for example, this one here, y is equal to a to the power of 0. Anything to the power of 0 is 1 due to our index laws. So therefore, it's just a 1 here. So if this is a 1, right? Now, they didn't ask this, but it's just as a bit of an extra. What would this one be then? What would the y-intercept of our graph be? Exactly. Thank you very much, Quinette. It will be -1 because it's just a reflection, right? Perfect. All clear, guys? Anybody have any questions on that? And good afternoon to anybody that just joined a few moments ago. We're going over a lot of random past paper questions. And what I'm going to do, I'm going to upload this lesson on YouTube after. So if anybody came late, you'll be able to watch it. And I'll probably upload it probably tomorrow or on Saturday. Yeah? So that's part A done. Now part B, we've got part B to do. It says on the axis below, sketch the graph of y equals 5 to the x minus 1. Now, remember, what do you do with these questions? This is a graph transformation question. I'm going to replace the y with f of x. And we know why we're going to do that, because we're going to say, okay, well, f of x is equal to 5 to the x. Yeah. And then now, I'll put my YouTube after the lesson. Yeah, don't worry. So we've got f of x is equal to 5 to the x. Now, what do we say here? Well, I've got 5 to the x minus 1 that I need to draw. Now, I've got this here. Let me do it in a red color. Now, I've got -1 here. Now, how do we go from 5 to the x to 5 to the x minus 1? We just subtract 1 from both sides, don't we? So therefore, the new graph will be this transformation, f of x minus 1, right? Now we've got our transformation. We go back to our table, but remember, we're in an exam. We don't have this table the way we're looking at it right now. We need to have this table in our heads, right? So the transformation that we've just figured out was f of x minus 1. I'm going to write it here. Now, can somebody tell me, please, looking at the rules from 1 to 6, which rule is f of x minus 1 referring to? Is it 1, 2, 3, 4, 5, or 6? Easy. Thank you very much, Quinette. Kieran, Sarosh, is 2, easily, because it's f of x minus a number. Then you say to yourself, okay, well, what does it mean? It's a vertical translation down by d units. So if it's f of x minus 1, I'm going to vertically translate my graph down. I'm going to shift it down by 1 unit, right? So I'm going to go here. Well, we know, remember, the y-intercept of 5 to the x was 1, right? Now, if I translate this down by 1 unit, because it's going to be f of x minus 1, right? I'm just going to go down by -1. So therefore, everything will now change. Now, the x-axis is here. We call this line, right? Does anybody know what this is called, by the way? This is a line that your graph touches but never gets close to. It begins with an A. Do we know what this is called? It rhymes with isotope. Yes. Thank you very much, Anilio. It's asymptote. This is an asymptote, yeah? Asymptote. This is how you spell it. So what will happen is if everything shifts down by 1 unit, this is going to shift down too. So now the new asymptote would be here, right? It would be at -1, isn't it? Yeah, like this, like that. And then the graph will just go through this. I'm going to do it in a different color here. It will just be like this, right? And then remember, the y-intercept was 1, but I'm shifting everything down by 1 unit. So what would the y-intercept be now, guys? We're at 1, we're shifting it down. Exactly. It will just go through the origin. It will be through 0. So the graph will just look like this. Like that. Right? And can you see this graph has just translated downwards by 1 unit? That's why it's only 1 mark. You just need to know your rules very well. Yeah? Now, does that make sense, guys? Anybody have any questions on that just before we move on? Yeah? So just remember, you just need to know these rules very well. Yeah? I know majority of us are in Edexcel. It didn't come up on the Edexcel paper 1. I'm not sure if it came up on AQA and OCR, but It's all good questions, all the same. Yeah, cool. I'm not seeing any messages in the chat, so I'm assuming that this is all okay. I'm going to continue. We're going to do another question. Yeah. All right. Now, what should we do next? Let us do. You know what? Let's do histograms because that's always going to come up for sure. Yeah. It may come up with a non-calculator. It may come calculator. Let's do this one. Let's see how we get on. So got this here. It's a 4 marker. So I'm going to give you about 4 minutes to try it, and then we'll go through it together. Yeah. So have a read of it. See how you get on with it, and we'll go through it together very shortly. How do we find histograms as a topic? Put a 0 if I don't like the histograms, hate them, hate when they come up, and put a 10 if this topic is super easy. I wish every question was a histogram question because I get 100%. I want everybody to give me a number between 0 and 10, please, just so I have an idea as to how you guys find these questions. Okay. I can see an 8, I can see 2 8s, I can see a 1, I can see a 6, I can see a 7, 4s, 9s, 8s, 5, 7s. Cool, cool, cool. Cool. So yeah, overall, it's not one of the harder topics, but if you don't know what you're doing, it can be a bit tricky. Yeah. So for those of us that are closer to 0, right? You've got just to remind yourself of a few things, right? Now, whenever you're dealing with histograms, right? So everybody that's working for it, just continue. For those of us that are a bit stuck, just listen up. We've got a histogram here. Now, when we're dealing with histograms, we know that the area of a histogram represents something. Does anybody know what that is? When we're dealing with histograms, the area of a bar represents something beginning with F. Can somebody tell me what that is? Right, right, right. Thank you very much. Wow, you guys are just, it's too many messages. Thank you very much. Anelio, Shaquille, Quinette, Kieran, Alice, Sarosh, Anelio, Andreas. It represents the frequency, right? We know that when we're dealing with histograms, the area is the frequency of the bar, right? Now, if we read the question here, it says a histogram is drawn to represent the heights of a sample of women. 3 of the 4 bars are shown, right? Now, we've got the height axis, we've got the x-axis, and we've got the frequency density, right? And we know from the question that there are 74 women in the sample. But what do we have here, though? We have the frequency density, we have the widths of the 3 bars. Maybe we can calculate the areas of those 3 bars, and that will tell us how many people, or how many women, I should say, are within those 3 bars. And then that maybe we can calculate the other missing bar. Does that make sense? Remember, we've got bars here, we've got rectangles, we can calculate the area of them because we've got the distances on the bottom, the heights, and we've got the vertical axes, the frequency densities. So maybe calculate the areas of those 3 and then maybe take it away from the sample size, and then maybe that will be able to help you out. Yeah, so that's a little bit of a pointer. See how you got on with that. And by the way, maybe I need to zoom in a bit because can you guys see what's on the grid as well, by the way? Or is that all clear? Let me just zoom in a bit more so you guys can see that. Yeah, I think that's okay. So I'll give you guys about a minute more. Okay, okay. I think it's been about 4 minutes, so we're gonna go through this together. Now, if anybody's got an answer, right, please let me know. So just tell me what you drew on the on your bar, so what the width is, what the height is, and so on and so forth. Anyways, let's go through it together. Yeah. So a histogram is drawn to represent the heights of a sample of women. Three of the four bars are shown. The bar for 170 to 180 is missing. Yeah. Now, it says here there are 74 women in the sample. We need to complete the histogram. Okay, well, if we need to complete the histogram, we need to fill in the missing bar, right? The missing rectangle. Now, how do we do that? Well, to figure out what a rectangle is, I need to figure out what the width is and what the height is. Well, we know, as I said before, we know that the area of a bar represents the frequency, and we're given 3 bars out of 4. So what we can do is calculate the frequencies for 3 of them, right? Now, what do we have here? Well, we've got a rectangle that goes from 150 to 5 to 155. So the width is 5. The height is just 2, right? So for sure, this is 5 times 2. This one is just 10, isn't it? 5 times 2 is 10. And then this one here, this goes from 155 to 165. So the base is 10. And it goes up to 3. So the height is 3. That means that this one is 30. So this one has an area of 10. This one has an area of 30. And then this last one here goes from 165 to 170, sorry, which is 5. And this has a height of 4, right? Has a height of 4. 4 times 5 is 20. So therefore, we could say that the 3 bars, right, has a frequency of 10 plus 30 plus 20. Right? What's this equal to? 10 plus 30 is 40, plus 20 is 60. 60 women. Yeah? There are 60 women in the first 3 bars. Now remember, there are 4. So the remaining bar, the one that we're looking for, will just be the difference between 74 and 60. Yeah? Missing bar frequency. All right, FREC for frequency, is just going to be equal to 74 minus 60, which is equal to 14. How many of us got here? Yeah, the missing bar has a frequency of 14. How many of us got here? Brilliant. Well done, Alice. Well done, Ebony, Quinette, Sarosh, Naisha, Naya. Good stuff. Okay, now continuing. Now, remember, we're trying to fill in the histogram. They've told us what the width is of that bar, right? So I'm going to draw this here. Like this. Whoops. We do it one more time. Maybe we'll hook this. Whoops. Okay, perfect. Now we can see that it goes from 170 to 180, right? So the base of it is 10, right? The base of it is 10, right? We don't know the frequency density, or in other words, the height, but they told us that the area, well, they didn't tell us, we calculated that the frequency is 14. Now remember from the very beginning, the area represents the frequency. So therefore, the area of this is 14. How do we work out the area of a rectangle? It's just base times height. So if the area is 14 and the base is 10, the height is going to be 14 divided by 10, which is 1.4. So the height of it is 1.4. And in other words, it's the frequency density. So therefore, we're finished because we know the height of it is 1.4. So we just go to 1.4 on our graph. Now, there are 5 boxes between 1 and 2. So that tells me that each box is 0.2. So this is going to be 1.4 right here. So therefore, you just draw a line like this. I'm just gonna rub this out like this. Remember, you need to complete the bar, so make sure you draw it on the actual question. So it's gonna be like this here, like that. And obviously, you will have a ruler in an exam, so you do a lot better than me. But yeah, then you're done. Just put this here, and then it'll just be this, isn't it? Just make it gray, and you're done. Yeah. How many of us got this correct? And for those of us that didn't get this correct, is this all clear? Well done, Alice. Fantastic. Okay, good stuff. Good stuff. Well done. Well done, Alice, Emilio, Quinette, and Naya, Ebony, Nisha, Naya. Fantastic. Good stuff. All right. Cool. So we've got about 10 minutes. If I'm going to do one more question with you guys. Now, this is going to be a hard question. Where is it? Where's that question I wanted to do? Where's it gone? There it is. Okay. So this here, let's zoom in. Now, this is how many marks? It's 5 marks, right? It's 5 marks here. Have a read of it. I'll put it here. Have a read of it. See how you got on with it, and we'll go through it together in about 5 minutes. Yeah. So have a read of that. See how you got on, and we'll go through it together. Love this topic. Good stuff. Good stuff. And I've got a question in the chat. Is this an equation of a circle? It is. It is because we've got a circle here. C is a circle with a center origin. A tangent to C passes through the points minus 20, 0, and 0, 10. Work out the equation of C. Well, C is a circle, as they told us in the first sentence. So they're asking us to work out the equation of a circle, right? Now, how do we find this topic, guys? Put a 0 in the chat if I don't know what to do. I'm clueless. I don't even know where to start. And put a 10 if this topic is super easy. I know for a fact when this circle question comes up, I'm getting 5 marks in the bag easily. Not even up for debate. I want you guys to all give me a number between 0 and 10. Okay. So I can see a couple tens, which is good. I can see nines. I can see fours. I can see a couple of zeros. And I know that some of us aren't in year 11, so you may not have been taught this topic. So don't worry. I'm going to go through it very, very concisely and very, very precisely so you understand. But don't worry. And let's just see here. So what I'll do, for those of us that are a bit stuck, right? So basically, the way circle questions work, actually, I don't want to spoil it. Okay, what I'll do, circles are center origin. So basically, you have a circle, right? You have a circle, and for these, this is for those of us that are 0 and maybe haven't seen this topic before, right? Because I'm sure that there's maybe some of us that aren't in year 11, so you may not have done this yet. But basically, you know how you have a graph like this. This is a graph. This has a general formula y equals mx plus c. You have a quadratic like this. This is y equals ax squared plus bx plus c. Now, circles actually have an equation too. Yeah. Now, this is for everyone, by the way. What is the general formula for an equation of a circle? Can somebody tell me, please? What is the general formula for an equation of a circle? Because it's not given to us in the formula book. We need to know it. The question is asked us to work out an equation of the circle. If we don't know the general formula for an equation of a circle, how can we answer the question? Right. Thank you very much, Emilio. Thank you very much, Quinette. It's x squared plus y squared is equal to r squared, where r is the radius. Yeah. So to answer this question, well, we need to figure out what r is somehow. Yeah. Thank you very much, Anaya. Good stuff. Yeah. So I'll give you about a few minutes more, and then we're going to go through it together. What I would do for those of us that are a bit stuck on it, what I would do is try and visualize it. It says a tangent to C. So remember from circle theorem, what is a tangent? What does that mean? Try and construct an X and Y axis, plot in those points that they said that the tangent passes through, and then try and draw a circle and a tangent that reflects the question. Yeah. With these types of questions, you want to visualize it. You want to see the question. Because when you can see things, it makes it clearer as to how to go about it. Yeah. So I'll give you about 2 minutes more, and we'll go through it together. How are we all getting on, by the way? For those of us that are getting on with it, difficult. You're getting there. How are you all getting on? I'll give you about a minute more and we'll run through it together. Okay, it's been about 5 minutes. We're going to run through this together and see how we got on with it. So if anybody's got an answer, please put it in the chat, but let's go through it together and let's see. Yeah, so I'm going to put this one more time here. All right, so we're doing the past paper. We're doing the past paper. We're at the end, question 22. Question 22. It says C is a circle with the center origin, right? A tangent to C passes through the points -20, 0, and 0, 10. Work out an equation of C. You must show all your working. So for me, this is a circles question. They're asking us to work out the equation of C, which is a circle. So for me, the first thing that I'm doing before anything is, well, the answer to the question is the general formula. X squared plus y squared is equal to r squared, right? This is the answer. Obviously, we need to figure out what the radius is, but this here is our answer. This is what we're going to write as our final line. So for me, that says, okay, well, I need to figure out what the radius is somehow. Now, they've given us some information. There's a tangent to see. It passes through 2 points. What I'm going to do is I'm going to try and draw a sketch. I want to visualize this question. I want to see it. I want to bring it to life, right? So what I'm going to do is I'm going to draw a sketch of an axis, right? Of a pair of axes, I should say, right? Let's just say, for example, this is the y-axis and this is the x-axis, right? And then it says it passes through the point -20, 0. So let's just say, for example, let's just say -20 is, I don't know. Let's say -20 is like around here for some reason, yeah? And let's just say this is -20, 0. And then let's just say 0, 10 is up here, yeah? Maybe like I just want to make it so it's like accurate, but yeah, that should be fine. And then it has a circle like this, right? So, or maybe I should do it a little bit more just to make it a bit clearer. It's like, maybe I should do it like around, maybe here, maybe, I don't know. It doesn't matter anyway. It's just a rough sketch. And then it's a circle that goes through these points here, yeah? So I have a circle like this. It's going to be at the center. And then the tangent to a graph, right? Can somebody remind me, please, what does a tangent actually mean? What does a tangent mean? Right, let's just say it's like around it. Let's say the center's here, yeah? And then the tangent passes through those 2 points, yeah? So remember, a tangent to a graph is a line that just touches your graph at a specific point, isn't it? Yeah? Thank you very much, Anelio. Fantastic. It touches at only 1 point. So if I draw a tangent to this graph like this here, it will look something like this, yeah? Let's just say the tangent is like this, like that. Let's just say that's the tangent, yeah? And then to be honest, that will tell me. I'm going to move this here now. Maybe I should have done that first, to be fair. This would be 10. This would be 10. And this would be -20. Yeah? This is our tangent. Now, yeah, thank you very much, Grenette. Fantastic. Now, the question says we need to work out the equation of C. And what do we know about tangent? So for those of us that in my classes when I taught this topic, right, there is a circle theorem that I always say you should remember when you're dealing with these circle problems. What is the circle theorem I'm referring to? Exactly. Thank you very much, Nidio. The radius and the tangent intersect at 90 degrees. They meet at 90 degrees. They are perpendicular to each other. Thank you very much. Now, it's the same thing with these questions, circle questions, always the same thing, right? So I'm going to draw a radius here, right? A radius here, like this, yeah? And then this here is a right angle, for sure. This here is a right angle, yeah? Okay. Now, this is the center. This is the center, which is at the origin. This is the center here. And then our right center, actually. Okay. Now, we need the equation of C. So in other words, we need to figure out what the radius of the circle is, right? Now, how do we find the radius of the circle? Well, the radius of the circle is this distance here. Now, for me, looking at this, well, the radius of this circle would just be, well, I could make a right angle like this. I can make this here, and then I can make this here. This is a right angle here. Now, yes or no, guys, for me, looking at this question, do we agree? If I can figure out what this distance is here, and I could figure out what this distance is here, right? I could use Pythagoras' theorem to work out what the radius is. Do we agree with that? Yes or no? Is that clear? That's my train of thought. Yeah, cool. Well, how do I do that though? Well, if we think about it, it's starting at the origin. So let's say I called this x1, and let's say I called this point y1 here, right? Then it's just this point, it's just this point here. It's the coordinates. I call this point, I don't know, I'll call it A. I need to somehow figure out what the coordinates of x1 and y1 are, the coordinates of A. If I can figure out what that pair of coordinates is, then I can just plug it into Pythagoras' theorem with the base and the height, and I'm done. Are we okay with that? Does that make sense? Yeah? Good, good. All right. Now, how do we find that though? Well, for me, looking at this question, right? The point A is intersected by two lines. It's intersected by the yellow line, right? And this line here, the tangent. Yeah. I'm going to say point A, right, is the point of intersection of the tangent and the radius. Yeah. Now remember, with a graph and lines, every single line that you see on a graph has an equation. Doesn't matter if it's a radius, doesn't matter if it's a tangent. If I could figure out the equation of both of these lines, intersect them, I could figure out the coordinates of A. Now, with this one here, we've got two parts. We've got 2 points on this line. We've got the point on the tangent, right? We've got the point minus 20, 0. Yeah. And we've got the point 0, 10. I could calculate the gradient of this line by doing y2 minus y1. I could say, well, m is equal to, it will be, you could do either one. I'm going to do 10 minus 0 divided by 0 minus 20. 10 on the top, minus is a plus, so this is just 20. So therefore, it's just equal to 1/2, right? So the gradient of this line is 1/2, right? Now, if I want the equation of this line, I need the general formula for an equation of a line. Because somebody remember what the general formula of the equation of a line is? Right, thank you very much, Quinette. It's y equals mx plus c. Yeah, y equals mx plus c. So therefore, the gradient is 1/2, and the y-intercept is 10. Right? It goes through 10. So the equation of this line is just a 1/2x plus 10. Now, somebody asked me, why did I subtract 0? Because remember, when I'm trying to figure out the gradient of a line, if I have the point x1, y1, and x2, y2, right? The gradient is equal to y2 take y1, the y coordinates, divided by x2 take x1, the x coordinates. So all I've done is I've just applied that. Yeah, 10 minus 0 divided by 0 minus 20. Is that clear? For anybody that was a bit confused as to why I did that for this one here, is that okay? Yeah? Okay. Cool. So continuing, we know the equation of this line. The equation of this blue line here is y equals a 1/2x plus 10. Now I need the equation of this line, the yellow one, right? Now, can somebody tell me, or let me ask you a question. Do we know the gradient of that yellow line? Are we able to calculate it? Is there something that we should know about the gradient? Right. I can see yes, exactly. Thank you very much, Anaya and Emilio. Remember, these two lines, the blue one and the yellow one, are perpendicular to each other. We know from perpendicular lines that the gradient of one line is just the negative reciprocal of the other line, right? So the gradient of this one, remember, what I do is this. If I want to find the reciprocal of any gradient, I start like this, 1/2. I take the reciprocal of it. So reciprocal means you flip it over, 2/1, which is just equal to 2. And then I apply the negative. So I'm going to times by -1. So -2. So that means that the gradient of this yellow line is -2. Is that clear, guys? Yeah, thank you very much, Shaquille. Victoria, fantastic. Yeah. So now continuing, we're nearly done. Continuing, we know the gradient of this line. Yeah. M equals -2. Now it passes through the origin. So there is no y-intercept. So C is 0 for this yellow line. So therefore, the equation of this line is going to be y equals mx plus 0, which is just nothing. So it's just y equals -2x. Are we clear with that, guys? Yeah? So this here is one line. This here is another line. We all okay with that? Nearly done, don't worry. That clear? Okay, cool. Now remember, never lose sight of what you're trying to achieve. What was the whole point of finding these two lines? Because it's the point of intersection of that coordinate A, right? If we can find out the coordinate A, we can figure out what the radius is, and therefore we can answer the question. Yeah? Now, how do we find 2 points of intersection when we're given two lines? We've got these two here. We've got y equals a half x plus 10, and we've got y equals minus 2x. What do we use? What is it? I'll give you the initials. SE. SE. Exactly. They're simultaneous equations, right? But they both have y here. They're both y. So we can just say that a half x, 1/2x plus 10, right, must be equal to minus 2x. So that way I can just calculate what x is, right? So therefore we could say, well, we've got this here. If I move this over, it will be 2x plus a half x plus 10 is equal to 0. Now this here, 2 plus a half is just 2.5. It's just 5/2. So you could write this 2.5x is equal to minus 10, right? Because if I move the minus 10 over, yeah? 2x plus a half x is just 2.5x. And now to get x on its own, we're just going to divide by minus 10. We're going to divide by 2.5, sorry. So give us this. Okay, this here. This gives us minus 10 over 2.5. Whoops, need to get rid of the answer. Minus 10 over 2.5. And this is equal to minus 4. Yeah? X is equal to minus 4. And geometrically, that makes sense. I'm in an exam. I expect my x coordinate to be negative because it's on the left side of it. So that makes a lot of sense. So that's minus 4. How do I find the y coordinate? Well, it's just a simultaneous equation. We plug in x into one of the equations. And I'm going to plug it into this one because it's easier to work with. Y equals minus 2. X is minus 4. So it's minus 2 times minus 4. It's positive 8. Now, why is this helpful? We now know the point of intersection of A. What was the whole point of it? Because remember, the x coordinate is the base of that right angle triangle. The y coordinate is the height of that right angle triangle. So therefore, if I get that right angle triangle again, I'll write it like this, like that, right? We now know the base of it, because it's minus 4 to the left, the base is just going to be 4. The height of it is going to be 8, isn't it? Right? Because we have a minus 4 here, and we have a 8 here. Is that clear, guys? Yeah, I'm just going to wait for anybody just to say yes or no. Let me just zoom out so you can see everything. Just going to wait for anybody to say yes or no, and we're going to round up. Yeah, good, good. So now, well, we can figure out the radius now, because it's just a Pythagoras theorem question. This is year 8 stuff. Yeah. R, which I'll call R, I'll call it R. R squared will equal 8 squared plus 4 squared. R squared is equal to 64 plus 64, whoa, 36. Whoa, that's definitely 16, right? R squared is equal to 80. Yeah? Yeah? So therefore, the radius is just the square root of 80, isn't it? But remember, the general formula is x squared plus y squared is equal to r squared. So we don't need the square root of r. We don't need r. We just need r squared, which is 80. So the final answer is x squared plus y squared is equal to 80. And well done to Anaya, because she gave me the correct answer in the chat. Does this make sense, guys? Should I make sure all okay? Sorry, we overran a bit today. Sometimes some questions require a bit more explanation. But is this all clear? Whenever you're doing these circle questions, and I'm pretty sure it's going to come up, you want to visualize it. Remember, it's the same thing. You have a tangent, you have a radius, you figure out the equation of them. And the key to these questions here, is always that point of intersection there. Yeah? Yeah? Cool. Cool. So yeah. For anybody that's a bit stuck on this, what I'll say is that what I'm going to do, just before I let you guys go, I actually give access to these notes. So what I'm going to do, if you guys check the chat in about 5 seconds, I'm going to put the link in for these notes, right? So some of you will probably have this already, but let me just get up for you again. So if you check the chat in about 5, 4, 3, 2, 1 now, there's a link that I've sent. It's onedrive.live.com, blah, 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 blah. Yeah. If you click on that link, should take you to our notes, right? So I'm going to share my browser so you can see. So this is the link that I sent in the chat. If you click on it, it should take you to this. You just go to GCSE Maths webinar. This is the lesson we did today. You're going to go to 1st of June 2023. You're going to go to higher exam questions, right? And then you're going to, as you can see, it should load in a second. Yeah. As you can see, these are all of the work we did today, right? And any questions that we didn't do, there's a June solutions section, so you can just check to see any questions, yeah? And for those of us that aren't in my group classes, what you can do with the link now, I teach these classes every week, and I've been doing lots of different topics. So what you can do, you can just go on any of these days, and from September last year, I've been doing these classes every week, done loads of different topics. You can have a look at any topic here, and then you'll see loads of questions. So for example, graph transformations that some of us didn't know how to do. I did it on the 3rd of January. You can just check here. You can see different questions here and workings out. Yeah. So I hope that's all clear. And for those of us as well that are having their first class with me today, I'm also on Instagram, which is here. It should load in a second. And I'm also, yeah, this is my Instagram here. This is my TikTok. I'm on TikTok now. It's been quite good for advertising. So I'm going to be uploading a lot more videos just up until your last exams. And I'm also on YouTube as well. So what I'm going to do is I'm going to upload this class. I'm going to upload it to my YouTube channel probably on Friday or Saturday when I've got a bit more time. Yeah. But yeah, that's it, guys. How do we feel? We feeling okay? Feeling a bit better? How you guys feeling about your exams coming up for maths? Yeah, good. Good stuff. Good stuff. Good stuff. Cool. So yeah, we'll leave it there today. Good luck. Nervous, don't worry, you'll be fine. Yeah, but good luck for your exams coming up, for all of them, for maths as well. I'm sure you guys will do very well, and I'm sure some of you I'll see again in my group classes. So yeah, good luck again, and I hope you found that beneficial. Take care. Yeah. Okay.